Hello. Good morning, madam.
Hello. Good morning to all. Good morning, sir. Shankar sir.
Good morning. Can you hear me?
Yes, sir. You are audible.
Okay, fine. I'm loading.
Sir, are you ready? মানে আপনি রেডি হলে বলবেন। ওকে স্যার, আপনি রেডি হলে বলবেন। আর পল্লব, হোয়াট অ্যাবাউট দ্য স্ট্রিমিং কখন স্টার্ট হবে সেটাও বলো। হ্যাঁ,
গুড মর্নিং ম্যাডাম, সুধাংশু বলছি।
হ্যাঁ, গুড মর্নিং
ম্যাডাম, লাইভ স্ট্রিমিং ওকে আছে, শুরু করে দিতে পারেন।
আচ্ছা, তাহলে স্যার রেডি হলে উইল স্টার্ট। ওকে।
হ্যাঁ ম্যাডাম, চালু হয়ে গেছে।
ওকে।
Apple, Delhi, yellow, red. Calcutta, Port. Port.
Good morning.
Good morning, sir. Good morning to all the participants, our respected Dean R&D, faculty and staff of Electrical Engineering Department of Travel Institute of Technology. Welcome to the day 5 of short-term training program of recent trends in application of IoT and condition monitoring for distributed generation. So today our distinguished speaker is Mr. Shankar Mukhopadhyay. Let me take a few moments of reading out his profile in brief. Mr. Mukhopadhyay is a graduate in electrical engineering of Jadavpur University in 1983, and he has 36 years in power sector in GEC, Tata Power and CSC Limited. He has worked in operation and maintenance of both generation and distribution sector. He has worked in power system operations, load flow and load planning and commercial functions in power business. Since the last 10 years, he is heading the Asia Institute of Power Management and Consulting ASC, and expanded the institute with all India repute, having clientele from all parts of India and abroad. He has proven expertise in business development related to power and energy sector. He is a chartered engineer of the European Council, the chairman of the Institute of Engineers and Technologists, and LG auditor. He has also worked with renewable energy and passionate on sustainability. So now the session is all yours, sir. If you are ready, you may start your lecture.
This is something new to me in the new normal scenario. Earlier, whenever I had give my dissertation lectures, I used to see the faces of the participants, and it makes me, more jubilant. While seeing their faces, I could understand that what is their queries, and where should I, stop or should I expand. But this is something, I need to see the faces of all the listeners. Basically, imagining their facial expression. So if you get bored, you please write a post that you are not enjoying. I'll try to, deviate from that topic, or I'll try to modify. Anyway, this is just the beginning, and let me start my dissertation. First of all, I thank JIS and Naumita to call me here. I do not belong to academic discipline, and I am not expert of this IoT topics, but as I have been working long with power sector, I can share the development of power sector and the present requirement of IoT related activities in the ongoing power scenario. The world and the India as well, both are changing their working styles. In every aspect, India is little bit lagging behind, but trying to cope up with the present progress. And we are now trying to develop ourselves from the status of developing to fast developing, right? And let me start with industrial revolutions. As you know, that industrial revolutions can be divided into 4 phases. In the first revolution, new sources of energy were discovered to run the machines. The mass extraction of coal and the invention of steam power plants were significant development stages in this phase. The second revolution, known as mass production of electricity generation, was a period of rapid development in industry, distinguished by large-scale iron and steel production. That was the construction period. That is the level when man-made energy, human energy, got transferred to machine energies. During this phase, many large-scale factories with their assembly lines were established and formed new businesses. The third revolution introduced computer and first generation of communication technology, which is little bit prevailing in India right now, with the advancement of telephone system, which enabled automation in supply chains. But the present day of development, which is the level of transition, a large variety of modern technologies such as communication engineering, communication system, intelligent robots, and the Internet of Things, IoT, are striving for the 4th industrial revolution. By allowing them, people, data, and processes are right now combined together. IoT can help improving different processes to be more quantifiable and measurable by collecting and processing large amount of data. You all know this. IoT can potentially enhance the quality of life in different aspects basically in service sector and in electricity services as well, which is manifested in smart grid activities. This is enabled by providing an increased automated decision making in real time and facilitating tools for optimizing such decisions. India is now at the process of transition. She has to increase the use of energy, but having deep shortage of resources. So the challenge is to have more efficient use of energy. This is number one. As we are having, shortage of resources, how we can manage with the growth. You must appreciate that we should be more and more efficient in usage of energy. And number two, harnessing natural resources, naturally available energies, which is not detrimental to the society. I will gradually come to this level. At this backdrop, we start the discussion with a brief snapshot of India's energy scenario and the possible development with distributed energy and IoT-based smarter applications. So I'm starting with the main slide, first slide. It is showing our present network or present electrical grid, where you see all. Can you see the presentation? Is it visible?
No, sir, till now it is not visible. Now it is coming.
Okay.
Hello, sir, one thing more. Hello.
Yes.
Sir, one thing more. The participants are there in the YouTube and they will write the questions in the chat box and that will be conveyed to you after your lecture is over. Okay, sir?
Okay. Thank you so much.
Okay.
Now, I want to give a brief synopsis of the energy baskets in India. Let us have, I presume all of us, the listeners, are Indian, so let us have an idea, a brief idea of India's energy scenario. Let me start with the area of India. That is 32,87,240 square kilometer is the area, and population is around 1.37 billion. Our target is to become a 5 trillion economy. Regarding energy consumption, mainly electricity, India is the third biggest after USA and China. Our per capita energy consumption is 24 gigajoule. I'm talking about the entire energy basket, not confining only in electricity right now. And the world's per capita energy consumption is 76 gigajoule. That means we are consuming almost 1/3 of the energy requirement by the world. We have to grow up from this level because we need to grow. We need to become a 5 trillion economy. And India's energy resources baskets is that coal is 56%, crude oil 30%, natural gas 6%, nuclear 1%, hydro 4%, and renewable 3%. India import 200 plus million ton of crude, about 80% of total demand, 30 million ton of liquid natural gas, and 140 million ton of coal, which is about 45% of total energy and Spain. You can just imagine what the quantum may be, 10,000 billion Indian rupees. So, to remain energy sufficient and just to meet the energy requirement in India, we spend so much. And now if I go to the electricity field, you can see that how much we have grown. In 1947, when India got independence, our installed capacity was 1362 megawatt, and now we are generating, we have an installed capacity of 371.8 gigawatt. That means 371,000 megawatt. That means it's a very steep rise which we have done after independence. So we are growing, particularly in electrical scenario. Today, if we talk about Indian power sector, I spoke you that India, this is the third largest global power producer and consumer. India is the third largest producer and consumer of electricity of the world, with the installed power capacity of 371 by May 2020. The country also has the fifth largest installed wind capacity in the world. Still, we have many miles to go. We have large expansion plans, investment from the government under various schemes to reduce ATC losses. I will come to these ATC losses in due course, but just keep in mind that as we want to be more energy sufficient sustainable in India, if we want to have more per capita energy usage, then we have to reduce the energy losses because it is reducing our overall efficiency. We need to improve technical and commercial functioning of power sector. The government has invested a lot in 24/7 power for all. You must have heard that this project is on. Developing smart cities as what? Why we intend to develop smart cities? Because we want to reduce losses. We want to make systems to move much faster and making smart power infrastructure for the same reason so that decisions can be taken instantaneously and the customers who are paying a bulk amount for electricity bills, they should not have any pain in getting quality electric power. We need 100% complete 100% completion of rural electricity supply and giving electricity access to all, for which the government is continuously spending. We want to have robust growth in renewables and distribution generation. Wind energy is estimated to contribute 60 gigawatt, following by solar power at 100 gigawatt by 2022. The target for renewable energy has been increased 175 gigawatt by 2022, and again it has increased further to 275 gigawatt by 2027. Favorable policy for environment. The government has allowed 100% foreign direct investment under automatic route in the power segment and for installation of renewable energy. New amendments of Electricity Act 2003 is still on the anvil on RE policy and cost reflective tariff. So the government is investing from herself. The government is trying to bring foreign investment for environmental improvement, and the government is continually trying to boost efficiency so that the per capita consumption can be increased. Now, right now I will try to explain you the figure of Indian electrical scenario. For the ease of operation, India, as you know, it's such a big country, 32 lakh, more than 32 lakh square kilometer area. So you cannot imagine like a small village or small city, the networks will operate. So for the ease of operation, the country has been distributed in 5 regional grids, and all the grids are connected. So the name of the grids are, if you see from the north, this is the northern grid, which is comprising of various states, northern grids. Then the eastern grid, you see the eastern region, the eastern grid, the western grid, and the southern grid. And one for the 7 sister states, that is the northeastern, there is a small grid also, northeastern grid. Now the grids are having some peculiarity. What is that? As you see in the presentation, the northern grid is initially a deficit region, and it has got wide variety of atmosphere or the variety of climatic region. In the great north, you see the Kashmir and the Jammu and Kashmir. There are snow-fed run-of-the-river hydro, highly weather-sensitive loads. It also have the desert of Rajasthan, and so the industry-rich areas also there. The Haryana, Delhi region, the Rajasthan also has industries, and part of this northern UP and others where industries are available. So it has got both agricultural and industrial loads. The maximum load of this area is around 60 gigawatt. The minimum is 30 gigawatt, and average load you can presume it is of 40 gigawatt. The western region, which is more in industry-based areas, it is comprising of Gujarat, Maharashtra, MP, and Chhattisgarh. Their peculiarity is that long haulage of power from east to west, because I'll come to that. It has got industrial rich areas. It has got good amount of loads. So the demand, maximum demand is 55 gigawatt, minimum is 38, and on an average, this is 45. Then we talk about southern region. It was earlier a deficit region. Right now, it has become almost self-sufficient. It has got high agricultural load and reasonably good industrial loads. Its maximum demand is 45 megawatt, a gigawatt, minimum 25, and average 35. And lastly, we talk about the, the fourth one is eastern region. It is not having much of load, but it is resource-rich areas. The resource-rich areas are eastern region and part of western region. So, as it is a resource-rich areas, you can presume that most the thermal generating stations will be placed here, and from the generation to the load side, the current direction or the power direction will try to flow. So you can presume that the load flow will take place from the eastern region to the western region and eastern region to the northern region. Previously, there was also a load flow from eastern region to southern region, but right now, as I told, that southern region has become more or less self-sufficient, so there will be less flow from the eastern region to the southern region. And the last one is northeastern grid. As you know that the northeastern doesn't have much of industries, mostly forest areas and rural areas. The maximum load is 3 gigawatt. Minimum in winter, it is 1 gigawatt and average is 2 gigawatt. And the peculiarity of northeastern to other regions is that They have got good amount of hydro potential, but bringing that hydropower from northeastern to eastern is difficult. But because only through a very narrow region, Chicken Lake, this northeastern connected to the rest part of India. So if you go to particularly these areas, Aligarh and close to Bhutan, you see this Chicken Lake contains good amount of transmission lines from where power is coming from Bhutan or even from the northeastern to India. This is basically a NASA picture, which is quite interesting to see, which identifies through illumination that which are industrially rich areas. You can find that brighter illuminations indicates those areas who are industrially or those who have got good amount of urban locality. The peculiarity of India, as I told you, that skewed resource distribution, so it requires long haulage of power from where resources more, power generation is more. So from power generation area to load area, this good amount of power has to be transmitted, that we call long haulage of power. Resource inadequacy, the resources are not uniformly distributed, and we have got weather extremes. We have got Assam continuously rainy, and you see again nowadays flood has been cropped up in Assam. Assam, Guwahati is getting inundated, and we have got Rajasthan also. So good amount of diversity. I told you we have got our generation strength of 371.9 gigawatt. The breakup is here, you can see. Thermal is still the leading, then hydro 45.7. We have only 6.8 nuclear. Solar is 35.3. Wind is 38. So totaling solar and wind, we have got almost even less than 80 megawatt, 75, close to 75 megawatt. We have got both solar and wind. We have a small hydro. If you take that into account, it will cross 80. And we have miscellaneous. These are basically biofuels and others. So these are 10.1 as a whole. This is 371.9. Now this, I was talking about the resources. The resources means I'm showing you the energy map, which identifies the resources. The extreme right, you can see the coal resource, which is indicated by black patches. And you can see the coal reserve is about 101 billion. India is the 5th largest in coal reserve. And this 101 is a very conservative estimation. We have got much more than 101, but considering the forest reserve and the difficulty in mining, we have taken this figure. So considering the present RP, that is reserve versus production RP ratio, we expect it to last about more than 100 years. The mines are in Jharkhand, Madhya Pradesh, West Bengal, Odisha, and in Maharashtra. The solar potential in India is high, but there are, in fact, in the globe, if you see the solar potential, there are also higher potentials in India. The highest solar potential is available in India, maybe in Ladakh areas, where the temperature is low and the cleanliness is very high, so the solar luminescence is pretty high. So you can expect a much big quantum of solar generation from there. However, more or less, it is equally distributed, little more distributed in the western part of India, but more or less evenly distributed all over the India, rather less distributed in the West Bengal region. But you can see the lines that in India, the solar energy available in a single year exceeds the possible energy output of all the fossil fuel energy reserves. So we need to harness more and more solar. And accordingly, the government has taken a decision to install a huge quantum of solar generation and integrating the entire power system. The wind power potential in India is 302 gigawatt at 100 meter or 103 gigawatt at 80 meter. I'm explaining what is this 302 at 100 meter and 103 at 80 meter. What happens that wind turbine when moves, it takes the help of wind speed. And as you know, when you move up from the ground level to the at a higher level, the wind speed increases. So at 50 meter level, wind speed, which is, for the low height wind turbines at 50 meter, what happens that the speed is so that you can get a generation of total, in total India is around 50 gigawatt, but we are very close to that. So right now 50 gigawatt is not sufficient for us. So we are thinking of putting the turbine at a higher level, and a survey of the entire wind map reveals that we have a capacity of 103 gigawatt if we make the next turbines at 80 meter, and much more, almost 3 times more, if we can increase its height, it's another 20. So the engineers are right now working for having wind turbines at a much higher level. This is basically, I am trying to show you the power evacuation network of India. You see the central ring, which is basically of 765 kV transmission lines, which is making a ring network. And from the pink arrows, which is directed towards this ring, basically coming from the resource-rich areas, they are putting power into the ring, which can be considered as a bus bar. And from there, the blue arrows, who are directed outwards from the ring, which are feeding the load-rich area. This is basically conceived India's one very, very high transmission line capacity. And another blue line you are seeing, which is the green corridor, which is being set up under the process of setup for the renewable generation. So renewable generation, we are right now talking about, our topic is basically distributed generation. Now what is distributed generation? Distributed generation per se, it is a renewable generation, but not in bulk quantum, renewable generation in small quantum, which is again coming as with a new concept of making a consumer to a different category, that the consumer will term as a prosumer, because while taking power from the grid, he is also having the capacity of generating power. He will be a producer and a consumer as well. So his term has been changed from consumer to prosumer. These will happen in distributed generation, and that will make, basically paradigm shift in the entire power scenario. I will gradually come to that. So it is clear to you that in India, the transmission network, this power is coming from load-rich areas where generating companies are more, and they are going to feed the grid, and from the grid, power is getting emanated to the load-rich area. So this is basically the transmission lines are set up with this concept. Now you can see the flow lines of powers. Again, what I told, this is basically depicted in this picture, not much to explain. You can well understand that from where to where the powers are moving. I'm changing the slide. Now, Indian power sector, the bare necessity. What is that? Growth of Indian economy is on the medium track. I am not talking about this year, because after COVID and even before COVID, the Indian entire economy was not in a favorable condition. Particularly in the last year, the GDP has fallen because of low industrial product, and there is, in fact, if you go through the global economy, there was a global recession. So everywhere the economy has not done well, and we have also not done well. And after this January onward, that is the onset of this new year, with this COVID, the entire economy is in shambles. So you can well understand that now whatever I'm talking about 2019, and whatever I'm foreseeing from 2021 onward, that presuming the COVID scenario will be over by the beginning of the next year. So let us not keep a mental taboo on today's incident, because we must consider this as an exception. An exception doesn't really prove the rule. So growth rate of Indian economy is on the medium track. We can presume that hinges on its ability to provide electricity, need to elevate the living standard, sustain economic activities, and improve productivity. So these three things are very important. So need to elevate living standard, because elevation of living standard means more usage of electricity. This is number one. And number two, elevation of living standard depends only when people have sufficient money to procure electricity and to buy more and more gadgets so that they can use more electricity. So they have to have a good amount of income too. That should happen only when if industrial activities begins at a much faster level. Now we can think that our Prime Minister has spoken about this Atmanirbhar Bharat, which if really takes place, then the scenario will be different. Per capita electricity in India today is 1181, that is even less than 1200, which is 1/3 of the world average. This is true. I talked about energy average, and again right now I'm talking about, which you saw that out of around 1/3 of the gigajoule energy which people per capita energy consumption was there. And today we see that 26 gigajoule and whatever we are consuming electricity, which is again world average, if you can see, close to 3,126, we are consuming less than 1,200, which is again about 1/3 of the world energy. This is basically a picture collected from the Wikipedia. You can also find out that what is the global average, what is the country-wise average, and if we think about China, it has crossed 4,475. United States, Canada, I am not talking about them because they are basically based in cold regions. They have got less manpower. They have got enough resources, so they can spend more. But we people should spend more electricity, not to waste electricity, but to put it in a productive form. So we need to increase electricity consumption. Now, India's energy challenge. India's energy challenge is basically things that growing electricity demand, creating pan-India market for renewable. What is today's problem? We are bringing more renewable. What is today's problem? We are having less demand, so we need to grow more electrical demand. Another thing is that India's international declaration under climate change seeks 40% of electricity. Installed capacity will be non-fossil fuel by 2030. Let me talk something on that. India is yet to achieve universal electricity access. We are talking about growth. We are talking about people empowerment. We are talking about more electricity consumption by the consumers. But today, the sad thing is that even electricity is not accessed by few of our countrymen. And the government has given due priority on making electricity for all, access to electricity for all. In my first slide, I told you, second slide most probably, I told you that the government is working very hard and we have given access to all the villages. But electrifying only one house of a village does not mean giving access to electricity to all of the countrymen. So, The program is right now to reach electricity to every household, that means every consumer. If we have got 138 crore number of countrymen, then if you assume that almost there are in every family there are 4 members on an average, then 138 by 4, that means almost 35 crore consumers are available in India, and you have to give access to them. But still, 1-2 crores, probably, I am not very sure, do not have access to electricity. And another is security problem. That is, India is dependent on oil import for 80% of its demand. So with electricity, if we can reduce some of more electrical energy, if we can supplement some of the oil energy, that will also be good for economy, where we are spending every year 10,000 billion dollars, 10,000 billion rupees. Imagine the figure, 100 million. I mean, basically 1 billion stands for a very, very big amount. You know that 1 billion is 1,000 million. That means 100 crore. So imagine what a big amount. So our demand is one area, renewable generation is another area, access to electricity is another area, security of energy is another area, and climate change is also another important area. And I'm telling you some of the small write-up on this. The global electricity demand rose at a CAGR of 2.5 to 3% till from 2010 to 2018. I am speaking on this climate change. As thermal being the primary resources, CO2 emissions increased substantially. You know that in India, even today, thermal is the prime generation. This CO2 emissions is threatening the world towards extinction if the temperature rise cannot be checked beyond 1.5 degrees centigrade. Thus, by the thermal generation is developing greenhouse gas and thereby increasing the temperature. If you even today or any day, if you open related, if you see Discovery, you will find that the polar region, the icebergs are getting cracked, melting of icebergs, and because of the temperature rise. So the global planet is the verge of extinction. And the global warming, if it exceeds by 2 degrees centigrade, we are going to face a very bad situation. Many of the places in India will get inundated by the rise of seawater. These are very alarming scenarios. So these will have a severe impact on the planet and human life. The environmental concerns such as global warming and local air pollution, scarcity of water resources for thermal power generation, and the limitation of depleting fossil energy resources raise an urgent need for more efficient use of energy and the use of renewable energy resources. So energy efficiency, I told you, one of the key drivers of sustainable development. Moreover, energy efficiency offers economic benefits in the long term by reducing the cost of fuel imports, supply, energy generation, and reducing emission from the energy sector. The energy supply chain includes 3 major parts. Firstly, energy supply includes generation from renewable energy resources with reduced and efficient generation from traditional system, because we cannot stop traditional system. What we can do, we can make traditional systems a more healthier system. We can't stop releasing CO2, but we can make better efficient. That means per unit of coal, the output energy can be more. So efficiency improves. I'm telling you from the earlier, this pulverized fuel boiler, when we are talking about supercritical boilers, that is subcritical to supercritical when you are elevating, we are basically increasing the efficiency. From a 40 megawatt, 60 megawatt generating stations, when we are increasing it to 500 megawatt, that is the economy of scale, we are improving the efficiency. So these are the objectives, how we must improve efficiency. At the same time, we will harness installation of renewable powers. May it be in bulk form, may it be in distributed generation, and I find distributed generation is more economic than bulk generation of renewables, because in every bulk generation, although you are generating in bulk, you are doing what? You are, upgrading it, you are utilizing first inverter, you are utilizing then transformer, you are stepping up the voltage, you are transmitting the power, again you are stepping it down. So every conversion you are using, basically technical loss is getting incurred, you are using some amount of energy in your system. Now coming back to our presentation, the Paris COP21, which has happened in 2015, India had made a commitment in Paris Climate Agreement to reduce emission intensity of the economy and having at least 40% of electric power installed capacity from clean energy sources by the year 2030. So we are working on a very steep target. We have got two focus. One is we must be in line with the global objective of mitigating CO2 release. At the same time, we are also trying to enhance our renewable generation to supplement even import of coal, import of oil, so that we can get a little respite to our economy, right? These are the breakers. And accordingly, we are increasing the installed capacity. In 2017, the entire installed capacity was 2017. The renewable was 18%. 2019, the renewables increased to 23%. Thermal was 66%. The thermal has been reduced to 63%. The nuclear, we are a bit conservative about nuclear. Because of various reasons, we don't have nuclear resources. We have to bank on other countries also, and we know the experience of Fukushima, Chernobyl. So still we are little bit skeptic on installing nuclear, but I think in future, to mitigate carbon dioxide and to have a stable power generation, we may have to increase more nuclear. Now, growth of renewable and solar capacity in India, I expressed you that this increasing is very fast. Basically, we are exponentially increasing this renewable generation. We are exponentially increasing the renewable generation. Again, this is a chart, sector-wise renewables as on 1/1/2020. This is wind power. Still, wind power is little more than solar power. We are in solar power, we are little bit less. This is small hydro. The figures are there. Cumulative as on 31/12/2019, that's 1st of 2020. And the biopower, this is almost 10 gigawatt, and the waste to energy, which is really very small. It is not that very economic, and getting resources also very difficult. But if we can be more, selective on waste, segregation of waste, the waste to power can also be a good input in our distributed generation. Why? Because this is, easily available in city areas, and many of the waste we do not see clearly. Many of the waste contain good amount of calorific values too. So if you can burn this calorific value rich waste to heat energy and produce electricity through combined cycle gas turbines, so they can give some amount of good energy. And waste, anyway, you need to get rid of this by a method of disposal. Either it will release stinking odors, or it will make your roads or areas, locations, spoil some areas with its, what should I say, with its nasty appearance and odors. So this is basically a good quantum for making energy. May not be, it can be produced in bulk, but it is good for the society. So waste to power, I also tell the participants to take care of that if something can be done. Now wind power achieved latest is that 37 gigawatt. Solar power latest is 31.379, but some quantum of rooftop is not added here. Solar power, the rooftop is 2.3 gigawatt, but it is somewhat more. Small hydro 4.6 gigawatt. Biopower, I told you, almost 10 gigawatt, and waste to power is almost 139 megawatt. So in totality, the RE basket is around 86 gigawatt. One point I should say, that whenever we are producing something, because I have been coming from industries, and those who are with the academic discipline, your and our viewpoints are a little bit different. Whenever we think that whatever we are going to produce, whether it has got a market, can it be sold? And therefore, the competition comes, and with the steep competition, the cost of energy of solar has come down drastically. We started in the year 2010 as 17.91, and it has come down to rupees 2.44, but such a low price in solar may not be sustainable. This is also my apprehension. And accordingly, the hydro power, the wind power has also had a value of 3.12, and it has come down to 2.43. But such a cutthroat competition and such a low price tag may not be a sustainable one. Particularly right now, we are having some problems in bringing solar raw materials from China. So if we want to bring it from some other country, the prices will be more. If we intend to set up the factories in India, because we are planning to grow much in solar, the cost of solar cells will be more, and same with wind turbines. So the cost, but we need not to be very fussy about the cost, because in India the average sale price of a unit of power is almost 5 to 6 rupees. So what is the point of producing electricity at 2.43 when a customer buys it at 5 to 6? So if we can improve the quality, if we can make it more Indian, and the price goes up, I don't think that will much affect the customers. Only thing what we need to improve our service system, we need to improve our supply system. Install wind capacity at states. This is just to show you that Tamil Nadu, because of its geographical position, it has got the highest capacity. It has got more than 9 gigawatt. Gujarat 7 gigawatt more than. Maharashtra almost 5 gigawatt. And so the West Bengal is not in the map, because West Bengal does not have wind potential, and we are also not much after this renewables. In fact, if you see solar, we don't figure in the pan-India figure. If we see wind, we also don't figure. So I am also requesting those who are interested in renewables, they can also, if you have got something, interest of being an entrepreneur, or if you want to have some research activities, you can also see and try to find out what is the solar potential, how much you can do, can we do at all anything here, or not, that can be also a part of your activity. Small hydropower, again it is less than 25 megawatt. The potential 21 gigawatt. Achievement so far we have got 4.4 gigawatt. This is one interesting curve I am showing you. All India Wind and Solar Power Daily Generation Report. This report I have collected from our regional power center. Interesting thing is that you see the blue line is fluctuating grossly, and that is the wind power. So if we talk about the reliability of generation, wind power does not have that reliability. It is very, very fluctuating. And solar, in such cases, has a little more reliability, but the availability of solar power is also an issue. It is only available so long there is sunlight. In the half part of the day, you are having solar. So CUF, when we talk about capacity utilization factor of solar, is almost 16 to 18, maximum 20 to 22%. It starts with 16 and ends with 22%. That is, basically it is termed as a plant load factor. That is the maximum capacity, maximum rating into 24 hours throughout the day, how much energy is capable it can release, and the numerator is how much energy it is releasing in reality. That is real output divided by the possible output. Had it been operating 24 hours a day, what much it could have operated. It is for thermal generation, it is much easier. It is termed as plant load factor, because thermal generation, you can, if you can give load, it can run for 24 hours with the same efficiency. But for solar and hydro, as the prime movers are coming from a different source, in hydro, in solar and wind, in wind the prime mover is basically your the wind speed, which is fluctuating. So you do not have any prediction of its capability, of its generation ability. And for solar also, you don't have any control on the sunlight and the incidence of sunlight. There can be cloud, so the sunlight will be less. There can be, rain, so the sunlight will get affected. And if there is, for wintry areas, if there is smog or if there is fog, the sunlight will get affected. So you have got more or less, do not have much control on this. Again, for a part of this. So CUF, the capacity factor for wind and for sun solar generation, which is low. For solar, it is 16 to 22% maximum, and for wind, it is on an average 20 to 24%. This is another curve. I'm showing you the installed capacity mix the country in the year from the year 1980, and it indicates that the renewable share, the green one, is increasing. The nuclear is maintaining more or less a steady mark. The gas plus diesel, it is again reducing, and the coal plus ignite, it is again for the last few years, it is again reducing. One interesting point I will tell you, what I have already mentioned, that plant load factor, which is happening in thermal, with more and more usage of renewable and hydro, if I can say, which is also right now falling under the category of renewables. The thermal generation, which should be, and right now that is happening, it is reducing its plant load factor. That means its operating time is getting reduced. But keep one thing in mind, this is affecting the economy also. Because when a thermal plant was set, it was presumed that it will operate at a plant load factor of 78%. Now we are not allowing it to be more than 57%. So how a thermal generation can survive? You can say for the sake of environment, a thermal plant shouldn't survive. But keep it in mind that since we are operating with some unstable generations, which is wind and solar, we have to supplement the entire thing with some stable generation. Today we are not that much, banking on the storage system. We don't have good amount of pump storage. We don't have good amount of electrical storage, that is, battery bank. So we have to depend on thermal generation for a longer period. That's why I was emphasizing on having more efficient thermal generation than thermal generation with lesser efficiency. So this is the talk of today. As although we have reduced the performance, the plant load factor of thermal generation, the coal consumption has increased. Why it has increased? Because the quantum of energy output from thermal, because every year we are increasing almost 4% in energy, 3 to 4% in energy. So as the energy growth is continuous, the share of thermal generation is also increasing, although we are trying to reduce its plant load. That is, number of thermal generating stations has increased, so each and every other generating station is taking up somebody's share. Those who are more efficient, they are getting more generation, they are getting more share. Those who are less efficient, their cost of energy is more, they are getting less share. But as a whole, each and every thermal generating station is consuming electricity, and so therefore the coal consumption graph has increased. We have to take care of that. When the coal consumption will be, stabilized, that is, it will not increase. Like, the corona graph, every day I see the newspaper or the internet, I see the number of recoveries are increasing, but the number of affected people is also increasing. That day I will be happy when I see that the number of affected people has been stabilized, and after that it has started falling. Then I will understand that really it is a check on the corona parameters. And same with coal, we must see that it has to come to a saturation. But still the saturation is not there. Here, the prospective figures 2021, 22, 26, 27, peak demand, what can be expected. Today our peak demand is 180 to 190 gigawatt. 2021-22 is expected that it will be 2025.6 gigawatt, and energy requirement billion unit is expected 1566. We are demand reduction due to DSM. What is DSM? I'm telling you. Let me talk about 2026-27. Peak demand is expected to be 298.8. Energy requirement 2047, and the energy requirement billion unit where this demand reduction is expected 206 million unit by DSM and 273 million unit by DSM in 2021-22 and 26-27 respectively. What is DSM? Because today we are planning to have more efficiency. We are stressing on what? We are stressing on supply side. That is a generation, transmission and distribution, where we have the power engineers have direct control. But who are consuming? They are consuming the same amount of energy what these companies are releasing, the transmission, distribution and generation companies are releasing, minus their own losses. These are basically as technical losses. Some theft is there. I am not considering the theft. We presume that the theft will be taken care of by the legal department, by the administration. Let us confine ourselves to the technical part. So ultimately, when a consumer receives energy, he becomes responsible for effective usage of the energy. But unfortunately, it is not done in that. Where IT and IoT has a great impact, can do a miracle. But even then, if the consumers are aware, if the consumers know that I can also manage my electricity, control my electricity consumption, and reduce my wastage by demand side management, the total word of DSM is demand side management. That is, the consumer is on the demand side, he should manage his side and try to reduce electricity consumption, not by reducing their product, reducing their usage, but by reducing their losses. So if such demand side management can be done by the entire consumer basket in India, it is expected that a huge quantum can be saved. That is, efficiency of the consumers can be improved. By 2021, it is 206 billion units, and 2026 it can be 273 billion. And this is another graph showing the renewable energy contribution in total energy requirement, projected generation from the renewable sources. These two are the figures. I am not stressing these figures, you can well understand. That is, if we can generate 175 gigawatt by 2022, the share of renewable energy will be 20.88%. Unfortunately, scenario 2, instead of 175, we can reduce it. If we cannot reach this 175 target, if we can reach 150 target, it will be basically 18.26%. If we further, restrict it, in fact, this may be a reality because of this COVID situation, then the renewable target will be 15.64%. I told you the wind is a fluctuating one. Now, so the wind target average we have taken. But day-wise target, you see, it is creating a huge fluctuation. This is solar, you can say 30 days average. Again, these are the averages, but overall you can see it is maintaining a more or less uniform figure. Now, this is an interesting figure. I just want to show you that if 175 megawatt comes, then what will be its impact on Indian load curve? This is basically the Indian load pattern. Right? Now, when the solar will come, this amount of power will be taken care of solar, so the thermal generation has to reduce in the day hour because you have to accommodate the solar power. And in the evening hour, particularly from this, when the solar illuminescence goes down, when the solar impact will be less, the thermal generation has to keep very agile to pick up their load. Problem is that the thermal generation, which is designed for 24/7 operation, that is continuous operation, they are not ready for shifting their services. If we do it, it will be an inefficient one, and for thermal stress, it will have much failure possible. So these are the important points to be kept in mind. So what we will do, what will be our cost, whether we stop thermal generations or block generations from those who are found to be less efficient. Only we keep some basic generations and manage the evening peaks through battery support or through renewable or through pump storage support. That's a question what the engineers are working very hard. Let us not toil our brain. I'm showing you the problem, and the problem has a solution. How far the solution and how close the solution can be done with the impact of this IoT based solution, that is a point we need to look out in future. Opportunities in generation catering beyond base load, the same thing, load curve. I am just requesting you to keep this load curve in mind. This is basically the load curve of keep this red area. This is basically a area basically fed by the thermal solar generations. Now you forget that there is no solar. So therefore, for India or say for any city or for any area, this is basically a common load curve. It takes the shape like that. It is basically a camel with two humps. The first hump is morning peak and the second hump is evening. And the load curve takes in this fashion. Now, I will come to you when I will talk about distribution. I think I do not have much of time, so I need to be much faster. So let us, I will just keep this thing in mind that basically a two-hump figure, when the distribution comes, how it can impact this. Now, future development was a part in my topic. So, expected future development in generation, what can be that? Supercritical boilers with higher efficiency, having the ability to burn inferior quality of coal. I told you that we need to be more efficient in generation. So, more thermal means more supercritical, more efficient generations, having much less auxiliary power, having much less environmental impact. And right now, you know that all the thermal generating stations having capacity more than 250 megawatt are getting installed with flue gas desulfurization plant. That is why, because we need to improve the environment. Augment hydro and renewable generation, reach on efficient solar power, tidal wave, wind turbine, geothermal energy, micro hydro project. So whatever renewable resources we have, we need to look into that. And how this can be supplemented the thermal generation, mainly the critical time of the thermal generation. That is the rising period. How best the rising period, 2 hours load, that is 5 to 7. This 2 hours load, when the sun is being set and light is, getting lit in the domestic and shop areas, how these loads can be managed. This is one of a very critical problem. Storage and battery. I told you the storage and battery, fuel cells, superconductivity, flexible solar panels. These are important research areas right now. Generation from alternative fuels like husk, sugarcane fiber, bagasse, even from garbage with calorific value. I talked about that. Transmission of electricity was generating in bulk and you need to transfer the electricity in bulk. So transmission of electricity is also very important in today's perspective. Large grids need to be protected from the threat of untoward incident with digital sensitive synchropressor worm system. That is protection from virus, malware, cyber security. This is a very important subject because today power engineers are prone to threat from other countries or inside the country or outside the country, not by missiles, but by some attack of virus, malwares. They can corrupt the entire data and make hell of the entire network. This is very important. Low impedance power transmission network, because we have got problem of ROW, right of way. Every cultivable lands where power transmission lines are set up, towers are set up, people are not willing to allow their land to use this. So how these lines can be made thinner but carry the same amount of load is a very important research area. Develop seamless connectivity to major load centers for ease of open access to bulk transmission. I am not emphasizing on this, is very important. Getting open access to bulk transmission. Establishment of transmission network for inter-regional power transmission of at least 16 lakh MVA in next 10 years. Huge setting up of transmission lines and correspondingly sub-transmission and distribution network to reach the newly being set up 16 lakhs MVA. That is the future demand which is being expected to come within next 10 years. And transmission of bulk and renewable power. Now, this is basically you are generating in bulk, you are transferring in bulk. But when it goes to the distribution level where we need the implementation of IoT more, generation we need to have IoT. If time permits, I can talk on that. Transmission requires IoT, but the most required area is distribution and the customer side, the consumer side. Providing 24/7 reliable power and quality power to all citizens of India, that is the job. First, we should be reliable. My electricity should go to, I am the electricity authority. My electricity will go to my consumer without any interruption. That is reliable power. And second thing is that when you get reliable power, surely you will expect that my power is reliable, but even in the evening, I see the tube lights are flickering. I see at times my fan is getting higher rotation, and at times I can see count the number of blades. What's happening? The voltages are not regular. So you talk about reliable power, but you are getting reliable power. You are getting power almost a day, but you are not getting quality power. So that is another important. Bring down the aggregate technical and commercial losses, ATC losses in distribution sector, less than 10%, like all modern countries. In our country, it is more than 20%. Even 25%, 26%, it is written in CA, it is 20.21%. But still, the exact data is not available, but one can be rest assured that it can be brought down to less than 10%. It requires huge change in the MBC system, that is metering, billing and collection system. Usage of proper meters for these crores of consumers, 40 crores of consumers, you can require 40 crore of meters. So you can right now presume that what a big market of meters is needed. And it should be suitably backed by IT, OT and automation. You cannot provide this IT, OT link for the smart meters everywhere because this is very costly. But you need to take care of these, seeing the nature of the business, that whom I will provide more costly meters. If the consumer consumes bulk, and if I don't get his correct bill, I will be losing in my business, then it will come in your mind that to whom are the consumers whom I provide good meters and good connectivity, good networking, so that I can get the correct billing and make the billing correct. Customer focus are the key stakeholders of the distribution business and developing efficient CRM activities. Mind you, tomorrow will not be same as today. You are selling electricity to consumers, they are buying electricity, they are paying for that. So you have to listen to their demand. And today, everything is government. Now tomorrow, if some private players do come, they will become petition. And they will try to prove their efficacy. They will have to be more concerned for the customer. Because the customer has the choice of changing the supply, which is true in European countries. Energy efficiency and solar renewable integration with the distribution network must run in tandem with the normal power purchase of a system. The taboo on DSM and solar installation must be avoided. May not be clear to you. I am not spending time on that because it is little bit difficult for the new people to understand. Now, let me talk to you something on future game changers. Future game changers are the area of electromobility where the liquid or gaseous fuel are being replaced by electricity. E-charging requires a stronger automated high-capacity distribution network, and this is basically, you are replacing the amount of petroleum energy with that of electricity. So presume that good quantum of electrical energy will be required. It will, the possibility of shortage of potable water. Today, India is facing water crisis. So you need to purify water. With demand of filtration, desalination plant will make the demand pool higher. India also being located in a subtropical region, and the global warming will make steep demand for air conditioning equipment. You all understand that every summer the demand of air conditioning goes up, and every time those who work in, those who are in their respective electrical authority, they apply for some additional loads whether shall be installed air conditioner or not. And the use of stronger communication, automation, and IoT applications are still strong growth engines for power demand and needs strengthening of distribution. Now, the role of digitalization in reshaping the electrical sector. This is basically, the transportation sector. There will be digitalization. The homes, digitalization, smart home. Industry, I told you, it's a very good area for using more IoT-based equipment for their energy management. Business houses, everywhere. And power generation, transmission and distribution all will be seamlessly connected to the system. Objective of a modern power company: extraction and treatment, primary energy supply, import and export, stock exchange. Now, in the primary energy company, in the energy power company, these are basically one basket where it is supply side. Supply side means you are extracting, you are getting the resource, either you are buying electricity from a different company or you are producing your own electrical generation unit. You are a primary energy supply, you are export from a stock exchange. Basically, this is a collection area where you are getting your electricity, maybe your own generation, maybe you are buying from somebody else. This converse transformation. Now, whenever it is a process system, whenever you are buying electricity or you are procuring electricity from your own resources, you need to convert. That means you cannot sell that raw electricity. You are buying it or you are producing at 10 kV, you cannot sell it at 10 kV. You are buying it at 400 kV, you cannot transfer it at 400 kV. So you need to transfer it through different systems so that it can reach to your consumer. Your consumer may be a low voltage consumer, your consumer may be a high voltage consumer. So depending on the consumer's requirement, you need to transfer it through what? Transmission and distribution system. In the well, some amount of energy loss will take place. You need to account for these losses. And through this, it is going to the final energy, going to the end-use appliances. There are also energy losses, and ultimately the useful energy going to the consumer. But again, this useful energy is useful to you, to an utility, because he is bidding for that, but it is not that useful to the consumer unless he takes care of his own usage immaculately without any unwanted losses. Losses will be there, technical losses you cannot avoid. But if you run the machine being unattended, it is freely motor rotating, then you understand say 500 kilowatt motor, if it is not loaded, it goes on freely rotating or pulling a conveyor belt with a static load. You imagine what amount of losses the motor is taking. You could have made a sensor so that when there will be no load on the motor or the conveyor system, the motor will stop. Could you not save some amount of electricity? These are the usage which is done by the by the IoT system. So the usage of IoT is becoming very, very important. And for distributed generation, let me tell a few words that distributed generation, suppose what happens that you are planning an electricity system for a small city and you are having some distributed generation. Say you have got 2 wind turbines, you have got 3 say some amount of batteries, some amount of solar. Now, in the evening hour, when or in the city, there are few industries also, small industries. Now, when the industries are taking load and your input quantum is becoming more, you can see, you can measure your input transmission line is on the process of crossing its limit. Suppose the limit is 50 megawatt. The input quantum has become almost close to 50 megawatt. Now, what you can expect? You can expect that you can draw further amount, but you have to pay a hefty bill for that. Is it clear to you, I think? that your limit is 50 megawatt for which you have set your system. Now, if you can draw more than 50 because some industry is taking more load. Now, if you draw more than 50, system will not stop you, but system will charge you a much higher quantum if you draw more than your allocated. Then what else you can do? You have got two things. You have got switch off some amount of load so that it can be contained within 50. You can do, or you can restrict the industry who is taking more not to take. But the industry has got definite necessity, so if it takes, it will be good for the industry. So you are not also intending to stop them. Now, what are in your hands? Either you switch off, or you restrict the industry, or you allow more load to come in, or the fourth one is that you allow some additional generation to be pressed into your system so that it can come. Now, if the industry has got a set of, say, diesel generator. Diesel generator is not a good one, but I am considering this just for the discussion. Now, if the industry sees that the system wants the diesel generator to be on, then the diesel generator will be placed into the service and the city demand will be restricted in the 50 megawatt zone. You forget about the city, you consider this is an industrial setup and the entire bill is coming through one unit and many other industries are sharing the electrical network. Now, this can happen to any of the industries. So, whenever load is coming, either you get some sensor, maybe it's a current sensor, it can check that it will be drawing more than the allocated demand, or if sudden load comes up, if the voltage dips, you can see that you are within the current limit, but for some reason, for some huge reactive pull in the system, the voltage has gone down. Now the voltage has gone down, you are supposed to operate at 11 kV input voltage, now voltage has become, say, 10.3. Many of your industries are feeling, much more current demand because the voltage has gone down, and some machines which are operated at very voltage sensitive, they are also stopped operating. Now, what you are expecting, you expect that some of the capacitor banks in your system to be switched on. So the IoT system allows the capacitor banks to be switched on, or you have got a different system of giving more generation to it. You have got a distributed generation system. Some wind turbine, it senses that the wind velocity is good and the wind turbine gets pressed into the sun. It is serving you both the reactive load because it is fed by a asynchronous generator. It can give you some inductive loads. At the same time, it is giving you some amount of power supply. So what is happening in a small system? If there is sensor operated IoT devices and checked with distributed generation, maybe it's a diesel generator, maybe it's a battery setup, maybe it's a wind generator, maybe it's a solar. It can happen in the daytime and solar system may be placed into service. So this thing can happen. So in a distributed generation system, if IoT systems are there, IoT operating systems are there, they can be operated very systematically and synchronously to get our system more sensitive, to operate the system in a more effective. The components of an IoT system. IoT employs sensors and communication technologies for sensing and transmitting real-time data, which enables fast computation and optimal decision making, and IoT transforms the sector to a distributed, smart and integrated energy system with distributed renewable resources such as wind and solar energy. Distributed generators are often termed as prosumers by aggregating their generation and optimizing their demand whenever useful for the grid. The application of IoT in the energy sector, starting from energy generation to transmission and distribution at the demand side, are the key areas for concern of all. Now, what is Internet of Things? Internet of Things, as I understand, it is giving in 5 different blocks. One is I01 IoT applications. The block 1, the circle 1 is IoT applications. IoT is an emerging technology that uses the internet and aims to provide connectivity between physical devices or things. Physical devices, which are basically the on which I operate, and the physical device and the internet. It creates a connectivity. Examples of physical devices include home appliances and industrial equipment using appropriate. Suppose this physical device may be in industrial equipment, maybe a capacitor bank or maybe a solar plant. This solar plant, when gets switched on by some sensor operation of, say, lower illumination, which is happening inside an industry, the light sensor operated IoT operates and gives information to the solar plant. The solar plant gets switched on and gives additional electrical power for the additional set of electricity and with electrical bulbs in the plant. So it's a simple operation of IoT-based things. Using appropriate sensors and communication networks, this device can provide valuable data and enable offering diverse services for people. IoT has a wide range of applications. Now, in Circle 1, the first step in designing IoT system. This is basically IoT application. The selection of components of IoT, such as sensor device, communication protocol, data storage, and computation needs to be appropriate for the intended application. The figure shows different components of an IoT platform, IoT devices. The second component, IoT devices, could be in the form of sensors, actuators, IoT gateways, or any device that joins the cycle of data collection, transmission, and processing. And IoT gateway devices enable routing the data into IoT system and establishing bidirectional communications between the device and gateway to cloud. The communication protocols, the third component of the IoT platform, enable the different devices to communicate and share their data. Basically, unless the IoT communicates, it is not possible to transfer the data. And making a decision-making center, IoT platforms offers the flexibility of select the type of communication technology. So when there is a communication, it has to depend on some communication technology. It can be 5G, it can be Bluetooth, it can be Wi-Fi, it can be ZigBee, it can be some other. And cellular technologies such as LTE, 4G, and 5G network, the data storage or the fourth component of the IoT platform that enables management of collected data from the sensors. In fact, this data storage is this 04 data storage is a very important area. And from the data storage, there is another part. The data collected from the devices is very large because it continuously goes on sending data. So segregation of this data and identifying the importance of the data and putting them into service is another area of very, very important areas, which is done by the data analytics platform. So I am having flooded with data, but what I will do with this data? These are done by data analytics. Now, this is basically a traditional power grid, and this is a smart grid. So this smart grid, is having all the generations, distributions, everything, but which are very intelligently coupled and can, talk with the own computer and take decisions on the system. Now, this smart grid, smart meter, and talking about a smart meters example, and you will understand that how the smart grids are operating. Smart meter is something. Meter, it is an instrument which is kept in a consumer to monitor the energy. Earlier and today, these are the prime concept of metering. Now the smart meters are little more than that. What it does, why it is smart? Because the smart meter can communicate. So whatever data the smart meters note, the smart meter requires that some action may be required on this particular thing. Suppose I'm giving you an example that how you tune a smart meter or how you advise or program a smart meter, it operates on that. You are having a smart meter in your home and you are connected through IoT devices, through your watch or through your laptop or through your smart mobile set. Through an app it is connected and the app is sensed by the IoT, which is kept in the smart meter. And you have got IP addresses both so that you can communicate to each other. Now what happens, you have instructed the smart meter that when I leave, say at 10 p.m., from 10 a.m., except my kitchen where your fridge are kept, all individual switches will be switched off. The smart meter accordingly carries the instruction. It has got some multiplying switches. It switches off all the instruments. And again, you have instructed the meter that at 6 p.m., usually when I return, all this will be switched on. Moreover, the AC to be switched on, when I enter, I must fill a code, ambience. So it does accordingly. So it follows your instruction. Again, the smart meter, you have instructed that if somehow the current goes up beyond this limit, you please give me an alarm. So you have set an alarm. If it goes beyond the entire, when you are in your home, you have switched off all the ACs, all the gadgets and everything, and you don't know the current has started increasing. So when you see a beep, you see that, okay, something has happened. Let me see. You see that the current has increased beyond the limit. So you check and switch off what is not desirable. So these are the things. Suppose a fault has taken place in your system and the smart meter gives you a beep that some huge quantum of current has gone because of this, and the smart meter is well trained, it has stripped its system because it has gone beyond the limit. So a smart meter can do these things and it can communicate you through a communication device. It can be any of the communication devices. Now, what are the communication devices? Wireless communication systems play a major role in. Now, the feature of smart grid, let me talk about the feature of smart grid. This is important, self-healing. I talked about consumer. The consumers want fast, some good behavior from the distribution companies. Now, one of the good behavior is that if there is any failure, how fast you can restore it, how far, suppose in Amphan, if you could have got your supply within 2 hours, definitely you would be very happy to the supplier because the supplier has given back your supply. You would have been more happy that if your supply won't have gone. But at least since an Amphan situation, you could definitely forgive the utility because such a difficult time. So if my supply goes for 2 hours, I won't mind. But if it goes beyond, say, 2 days, surely you will mind. Now, this is basically reliability and it has got a cost behind it. Now, self-healing is also an example of very high grade of reliability. What is that? If there is any fault in the network, the fault should get isolated automatically and your supply should be restored from a different region. So you would understand that there is a failure in the system, which we call self-healing in our system. Now, had the fault been healed by your system? No. It has got given you a different path so that you can assume that the fault has got rectified. For this, you need to have a standby source of supplies, number one. Number two, standby and automated of self-operating and very sensitive protection system, which can identify the location, zone, and isolate the faulty section and give your supply, sensing that your voltage is off. So it will sense that you have not yet got back your supply and put different resources and finally switch on. Everything will be done for it. It should be resilient against both physical and cyber attacks. So number one, it should be reliable, self-healing. It should be resilient. Third one, active participation by consumers in demand response. That means it is responsive. Demand response means when your demand becomes more, if the utility fills, if the demand becomes more, what happens? Two things. One, the voltage will fall. Second, the frequency will fall. So either voltage sensitivity or frequency sensitivity, you can assess the situation and take corrective action, which is again automatically. So some amount of load will be shed, some amount of voltage will be reduced, either blackdown effect, that is load shedding, or browning effect by voltage reducing. You can make your system back to normal. So this is sensitive. Accommodates all generation and storage options, that is uniform. It will accommodate all generation and storage actions, but it will put into service when the economy permits. Enables new electricity market, which is again of uniformity indications or economic actions. Optimize asset utilizations, so your assets should be properly utilized. The smart grid will take care of the asset management. Provides quality power. Today, consumers are not only happy in getting power, they are thinking about the quality, and it should optimize operating efficiency. The smart grid or the smart system is eyeing for that. It is ultimate objective is to operate with the highest degree of efficiency. Now, this is a conceptual model. Bulk generation, transmission, distribution, customers, operation, markets, and service providers all are under this bulk net of this smart grid, and everything is controlled by IoT. There is a communication network, home area network, HAN, neighboring area network, NAN, field area network, FAN, or wide area network, NAN. Due to paucity of time, I am not stressing on these networks, but I am giving you a very brief idea that there are so many technologies. That is LoRa technology, which is low range output, which is basically, power usage is very low, and range is almost 50 kilometer. Example, this is used in smart buildings or in smart grid activities also, because within a 50 kilometer range, if you've got an industrial setup, within the industrial setup, you can make this LoRa applications. NB-IoT, it is also a narrowband IoT. It is within a range of 50 kilometers. kbps is more, so you can transfer more data. Power usage is comparatively higher, and it is used for smart grid communication. There are others, LTE-M, which is used for 200 kilometers. This is used for smart meters. In fact, Calcutta smart meters, if it is installed, LTE-M can be used. Sigfox is another technology. Weightless, another technology. Bluetooth, all you are concerned, aware of Bluetooth. Zigbee, it is very common, and satellite, very costly, but it is also used for solar and wind power plant or remotely distantly located power plant. So these are the communications. Zigbee is given. I'm giving you a little bit more on Zigbee because it's very common. Zigbee is the most popular low-cost, low-power wireless mesh networking standard in the market right now. So in Zigbee, although the range is 100 meters, but with mesh networking, it range can be increased. It is typically implemented for personal home area network. Benefit of ZigBee is that nodes can stay in sleep mode most of the time, so battery consumption is less. It cannot easily communicate with other protocols. Additional mechanism is required to communicate. As I do not have much knowledge on communication, I cannot talk on this topic in details, but I understand that protocol is a very important issue for communication. So, and every network or every IoT equipment cannot communicate with other one. So there is a network protocol and interoperability issues are there. So that has to be taken care of. Since this is a developing subject, people working on this must know much better in this particular field. IoT role in smart grid, application layer, presentation layer, and perception layer. In 3 layers, IoT operates. Application layer means smart homes, smart cities, electric vehicles, renewable energy sources, power lines. Presentation layers, which operates with the networking, gateway, ZigBee, Bluetooth, Wi-Fi, and others. And perception layer, these are wireless sensors, RFIC, and cameras. They directly operate with the presentation layer. Now I talked about data analytics. So data center is important, where the distribution networks, power plants, smart factories, smart buildings, farms, all these data are, kept in the data center. And next thing is that the data center data, if it is, gets continuously reached with this influx of data, it will get overloaded. So in many cases, the data are kept free with that of cloud computing. So this cloud computing is also very important. Computing and analyzing the data generated by IoT allows accurate response to the system and helps making suitable decisions on energy consumption of the system. However, computing IoT data is a challenging issue because IoT data, known as big data, refers to huge amount of structured and unstructured data. As I told, that every data, if keep parked in data center, that will unnecessarily overload the usage of data. So duty and characteristics of big data, which are big volume, high velocity, and high variety, it needs to be efficiently processed and analyzed. Advanced computing and analytic methods are needed to manage this big data. And the following explain cloud computing and fog computing, so which are presently used. Cloud computing is a data processing approach that offers services, application storage, and computing through internet and allows computation of data streamed from IoT devices. Although, and fog computing is that, cloud computing is one of the best computing paradigm for data processing for IoT applications. Due to delay and bandwidth limitation, centralized resources that are used for data processing, more efficient ways are required. Fog computing is a distributed paradigm and can extension of the cloud, which moves the computing and analytic services near to the edge of the network. So both type of computing methods are used. Data analytics, many people, many engineers, technocrats are working with data analytics, and it is relating to new results, new type of decision making are coming through this. And artificial intelligence is based on these big data analytics. So this is a new and developing subject. It is getting integrated with power systems. And the role of IoT in home management and in smart grid. I have already given an example on that. IoT in smart energy applications, I also have spoken on that. So another point I just need to stress upon is that it is almost end of my presentation. That power quality, as I told you, it's becoming a priority area. What you are giving when a customer is buying, presume that he buys it with happiness or not. That is the ultimate criterion. If he is compelled to buy, and if he does not have any option, you must not be very happy because he is basically compelled to buy your product, your electricity. Had he been a choice, should surely have tried to get a different taste, different, different vendor you would have tried. But today in electricity, the opportunity is not there, but tomorrow the opportunity may come. So we must be very cautious about maintaining the quality. Quality maintaining does not only indicate on voltage, but indicate on frequency also, because we are supplying frequency, say 50 cycles, and voltage and 230 volt. Now 230 volt means it should be close to 230, and 50 means close to 50. But the utility is supplying 50, but due to various reasons, harmonics and other reasons, due to continuously usage of nonlinear loads, the harmonics are getting only present in the system. So you need to get rid of that, which also requires IoT services for making your system free from impure power quality. So the system is gradually increasing. It is gradually, overspreading with more usage of IoT and smart applications. I tried to, tell you something. I have, in fact, surely exceeded my time. So please excuse me for that and let me know what you have, whether you have enjoyed the session or not. Thank you.
Sir, it is an excellent and informative and mind-blowing presentation. Now, I am requesting the participants, if you have any question, then you can write in the YouTube chat box. Sir, I have a question.
Yeah,
Hello?
tell me.
Yeah, sir, is it possible to switch to a fully sustainable global energy landscape within next 20 to 30 years?
Global energy landscape, it's very difficult to say. In fact, you see that many of the countries, particularly in the European countries, they are trying to make their energy system, more to prone. I mean, green energy, more to green energy. Say Germany, say Norway, but India being a very vast country, and we don't have much of economic strength, so it is not very easy to convert our system to a green one or zero carbon with zero carbon footprint. But we must go on trying, and the less we can release CO2, the less we can pollute our system, the best we can do for ourselves. Right.
Okay. Questions? So, on behalf of the Electrical Engineering Department, sir, I am sharing the certificate of appreciation.
Thank you.
Sir, is it visible to you?
Okay.
Thank you, sir. I joined late. I actually, our meeting will start. It's Navamita here once again. So thank you, sir, for joining with us here.
Yeah, I got your certificate. Thank you so much. I know that I have, exceeded my time, so I'm extremely sorry for that, because when I talk, I just forget of, checking my watch and what had it in my mind I wanted to express. So thank you very much for giving me the opportunity. Thank all the
Sir,
participants.
it was an excellent presentation, and thank you for sharing your valuable time with us and also the knowledge. We hope to have the opportunity to get your such enlightened lecture again in the future. And I want to extend heartfelt thank you for contribution to making this session so successful. Thank you, sir. And our next session is starting. So I am requesting Ms. Kamalika Banerjee to next lecture session.
Thank you, Priyanjali madam. Uh, a very good afternoon to all the participants and respected delegates present over here. So I feel honored to introduce the next speaker for the session, Professor Dr. Paromita Chattopadhyay. So it's my privilege to read her achievements. Professor Paromita Chattopadhyay received the BE, ME and PhD in electrical engineering from Bengal Engineering College and Science University, Shivpur, India in 1993, 1996 and 2002 respectively. Currently, she is an associate professor in the Department of Electrical Engineering, Indian Institute of Engineering, Science and Technology, Shivpur, formerly Besu, Shivpur, India. She received Young Scientist Award, DST, Government of India, and Commonwealth Fellowship UK in the year 2002 and 2003, respectively. She was the visiting professor in Hanyang University, South Korea in the year 2008. She has executed number of sponsored research projects funded by DST, AICTE, CSIR, IE and NPP projects of CPRI, Ministry of Power, Government of India and developed laboratory with the state of the art facilities in the area of condition monitoring of rotating machines. She has published more than 50 research papers in various international journals and prestigious conferences and filed 2 Indian patents. She has already guided 3 PhD and 25 MTech theses. 4 more PhD scholars are working under her supervision. Dr. Chattopadhyay is an IEEE member. She has already taught the courses like electrical and electronic measurement, signal and system, soft computing, AI and ANN in undergraduate level and conditioning monitoring of electrical equipment, application of soft computing in electrical engineering in postgraduate level. She is a passionate researcher and her research interests include condition monitoring of electrical equipment, machine learning, signal processing, design and development of intelligent systems, AI based smart grid management, energy informatics, learning in control, and applications of nanotechnology in power and energy sectors. So, with this introduction, I would like to invite renowned Professor Dr. Chattopadhyay, to start the second session of this STTP program. Thank you, madam.
Thank you. Thank you very much for your introduction. So let me start the session. Very good afternoon to all of you. So let me share my screen first. Okay. So is it visible? Hello? Hello?
Yes, madam. It is visible, madam.
It's okay. Okay. Thank you. So, let me start. My topic is energy informatics. In the last session, already the speaker has already done a lot work for me. So I think I don't need to spend much time on the introduction part. But still, I would show you some couple of slides just to prepare the background of my lecture. So this is the layout of my talk. I would start with introduction, where the new things which I would like to mention is the big data issues, sensors in smart grid ecosystems, Then I would come to the topic energy informatics, its definition, objective, and scope. Next, it would be the deployment of smart sensors and energy efficiency. Then the last but not the least is wide area measurement system based intelligent monitoring and control, where I would try to emphasize the renewable energy integration and its negative effect on grid stability, and where is the need for wide area measurement to mitigate that negative impact. Next, the phasor measurement unit, which is the heart of the wide measurement systems, then followed by the PMU-based data analysis, tools and techniques, and deep learning-based grid event classifications. Lastly, I would like to mention the challenges and open issues and future scope in this area and the references. So we all know, you know, because you are at the end of the this program, so you all know that the energy plays a very instrumental role in any development, socio-economic development and of the country. It has a very good correlations with the GDP and the economic development of the country. So if we look into the energy map of India and some of the developed countries, we would see that the per capita energy consumption of India is much less than the per capita energy consumption of the developed country. This is the per capita energy consumption of India, and this is the per capita energy consumption of the Europe. So in future, India need energy, but normally, even if in our 10 years back, energy means we understood the traditional fossil fuels. But you all are aware of that in the year 2015, our common future under climatic change in the Paris in July 2015, we all the consensus among the climate scientists, it is clear that this man-made greenhouse gases are leading to dangerous climate changes. So as a result, what we are getting global warming and some adverse effect on environment. So in that, so 2015 is the pivotal year for in energy roadmap, where the scientists took an oath that we must have to effectively manage our load, we have to reduce the losses, and we must have to integrate large amount of renewable energy generation to get a sustainable development. That means basically we have to reduce the carbon footprint. That is the main major motto. So the Paris New Climatic Change Agreement, the three important steps were taken that you already know, that is the reduce carbon footprints, increase renewable energy, and the energy efficiency. So these 3 points are introduced. So to reach this reduction of carbon footprints, increase renewable energy and the energy efficiency, what, as a power engineer, what can we do? So if we look into the global carbon dioxide emission by various sectors, we would found that the industry, they are the major contributor, followed by the buildings and the transportation. So we would focus on this area, how we can reduce, make this areas energy efficient. So, these are some figures, some statistics, or I'm showing where the greenhouse gas mitigation versus cost-effective energy efficiency are represented. From here, you can show that the orange color, it is indicating that it is very easy for the building to make it energy efficient. Low cost emission reduction, because we can, if you just invest a very small amount, we can make it energy efficient. And another area is the transport also. It is possible to make it energy efficient. And another area is the energy supply. So our building, transport, and the energy supply, these are the low cost emission reduction is possible. So these seven are the method areas where we can reduce the greenhouse gases, but these very transportation and the building are the three important areas where we can reduce the greenhouse gases in a very cost effective way. So here I am representing some low carbon hierarchy, that when we are talking about we have to reduce the carbon footprint. So how can we do it? The first thing is that we can reduce our demand. Second is we can make our system energy efficient. Third option is the renewable energy or integration of renewable energy, because as here I'm showing the cost, because as we are moving upwards, that means its cost is increasing. So first cost effective thing is to reduce demand. Reduce demand means not only reduce demand, but without hampering our comfort level. And then we have to design for the energy efficiency. And third one is the renewable energy integration, because the renewable energy integration is not very cost effective. So in rest of the part of my lecture, I would try to emphasize how we can make reduction of our demand without reducing our comfort level. How can we make our system energy efficient? And finally, definitely we would come, because these two sectors we can contribute, but we must have to integrate the renewable energy to meet up our ever increasing generation. So these are the typical share of renewable energy in India. Already, I think you have seen several speakers have talked with you. The major thing which I would like to emphasize, that the coming years, what is happening from here, you can see that the integration share of various renewable energy is day by day increasing. So the new power capacity which is installed addition in India, they are mostly of renewable energy in nature, which is indicating by this. So the major share showing 2018, 4% of the new energy capacity was in the area of renewable energy, and where major share is the wind, then the solar and the biopower and the small hydro. So as my earlier speaker, they have also mentioned that we are moving towards a smarter grid. That now question is, where is the need for the smarter grid? Because as we have mentioned earlier, that we need to improve our environment. We must have to enhance the value for the energy, improvement of energy efficiency, and we have to improve the quality of our life. So there are both economic and environmental urges for transmission from the current updated power grid to a sensor embedded smart grid that monitors system stability, integrated distributed energy, and scheduled energy consumption for household users. So mainly we are moving towards the smarter grid from two important concern is there. One is environmental issues, another is economical issues to make the system energy efficient